Hi everyone. First of all, I'm real glad to be here. For so long we haven't had these in-person meetups, and it's so great to be here. And just realized that you had right now just 2 Israelis in a row, and well, I hope you're surviving us here. So let's talk about CVEs, vulnerabilities, and the perspective of them. So just a few words. We don't have a lot of time. So I'm Ben, VP R&D at Armo. We are the main maintainers of Kubescape. And from my background, I started as mostly offensive security professional, and turned into developer, then R&D and stuff. Pretty active in CNCF, and yeah, that's about me. And we are at Armo. We're a small yet successful startup in Israel, dealing in Kubernetes security. So really, you should check out what we are doing, and especially Kubescapes. So why to scan? Okay, why vulnerability scanning? And the question is, the first answer for us as those who are operating, live systems, and we have a bunch of things to do around our live system and maintaining them and operating them. The third thing is that our, security personnel in the organization told us to do. He told us to scan, okay, our containers, our nodes in our live systems for vulnerabilities. But obviously, this is very, very shallow answer. And the second step in this answer is that he's asking us to scan for vulnerabilities because there are compliance frameworks asking him to do that. And I can talk about a few of them, but that's not really interesting. Okay, you can. I'm sure that you know most of them better than even me. Okay, and you can see that in SOC 2 you have to prove that you are scanning all your application, all your nodes for vulnerabilities, and you have a policy in place for fixing them and rolling up fixes for them. But the real reason for that is, obviously, if you have vulnerabilities in your applications or in your underlying infrastructure, okay, you have to deal with them. You have to know that they exist, right? You have to know that there is an issue, a potential issue in your system. And then you, as a system operator or administrator, you have to start to either fix them, okay, if you have fixes for them, or let's say, minimize their effect. What does it mean is that you're actually investing a lot of time in this, right? Because you're finding out that you have some security issues, because it's not like your Android or iPhone where the vendor is pushing you security updates from every week or two, but you have to deal with this. You're the owner. And you're investing a lot of time in this, and especially in the part where you're fixing, okay? And not just when fixing, but you'll see that in my presentation that even before fixing, you're investing a lot of time in this. So let's talk a few words about vulnerability scanning. How's it working? So vulnerability scanners needs to produce a list of vulnerabilities in our software packages, or containers in our case. So what they are doing is, actually they are getting 2 inputs. One input on which they are working is a list of software you have in your container. Obviously you need to know what you have, okay? Otherwise you cannot find out, okay, what kind of vulnerabilities you will have. And the second thing is you need to have some kind of a database where is a listing of information of connecting, the software name or software component name to a specific vulnerability, because someone found vulnerability and the vendor and software vendor released an information to the public that you know that in my software, for example, I don't know, libc has a specific vulnerability, and you know, in a specific version, and I want you, as a software vendor for libc, I want to let you know about it. So the first part is tricky, okay? And I think that in order to understand what are the hardships around this whole process is to understand, okay, how this discovery is working. And it's really controversial. I can tell you from as a security persona myself, I can tell you that by itself, this is very, very controversial process, because as I told you, you need to have a list of software you're having in your container, right? And as all of you know, I guess, that Docker containers are not coming with a list of software installed inside the container, at least not explicitly, okay? So this list is called SBOM, Software Bill of Materials, okay? And SBOMs you are not required to provide them and as a software vendor, and the federal government is preparing a process where software vendors will be required to do that, but you know, it's still in early phases. And if we don't have it, okay, and we don't know, I give you a Docker image and you don't know what is exactly included, what are software components inside, the question is if we can create one. And the most simple, even naive approach is to look into the distribution package manager inside that container. So the way we are building container images is that usually in the base image, we've installed distribution package manager, okay? So it's like when it's maybe an Ubuntu or Debian or CentOS or Alpine base image, and you have their package manager with them deb, with apt and yum and so on. And what you have inside when you are using in the respective layers the package manager to install specific libraries inside your container, it not just installs the actual files, but it also keeps a log of the installation, right? Because every package manager, not just installing, packages, but it needs also to be able to update them, right? Or even uninstall them. Therefore, it needs to keep a log of list of files which are related to a given package. Therefore, what we can do in the package discovery is actually we can say that based on this installation log, okay, we can recreate an SBOM for a container image, right? No, right? It's not true. So the answer is obviously it's not enough, okay? It's way not enough. Think about everything which was installed in a container image, which are language-specific packages. So not the classical package managers have installed them. So obviously, a good scanner needs to support it. It needs to identify jar files and read their metadata objects inside in order to understand what is this software component, or pip for Python, and so on. But if we're looking at, I can also tell you that this won't be a complete software bill of material file, okay? Because we have multiple other things here missing. But just for to show you a very, very simple example, okay, an SBOM output will look like something like this, where you have here package name, and beyond the package name, I don't know if you see it, sorry, but you also have a version. These are the two key components, okay, of every entry in an SBOM file. So a package name and a version. And this is going to be crucial for this second part of the discussion, but also keeping, obviously, inside the SBOM, you will see the list of files which are connected, okay, to this package. Now, the other part of the discussion is, okay, we have most likely not a good list of software components, but we have a list, okay? Now what we do with it? So every big Linux distribution releases I'm calling that vulnerability database objects, which are actually a mapping of these software components and their versions to specific vulnerabilities. So it's something you can easily download from the vendor's website. It's a very, very simple table, and you can see what are the vulnerabilities the vendor knows of them. And also the emphasis here is what are the vulnerabilities the vendor knows about, okay, and not those which he doesn't, okay. Now, what about things which haven't been part of the packages, which weren't part of the Linux distribution? And as of today, in the past few years, we saw a big progress on them, because you can see that today GitHub is releasing vulnerability information where they are interconnecting software components and their versions with the known vulnerabilities. Also, Google is releasing, and there are a few others. So we can see that also not just in the Linux distribution world, but also in other parts, we can see that software components are starting to, in a general way, release information about their vulnerabilities. So we have a list, of vulnerabilities. So returning to the original diagram, you can see that here in the up, we can see that we have an SBOM. We create a list of software and their version, and we've downloaded all this vulnerability information. And the scanner, what it does, it's actually, crosses these two information and saying that, okay, for example, like in login package or ncurses package, you have a given vulnerability CVE with its specific severity, and create this list of vulnerabilities inside of your container. So there are a few problems here, okay? Because you already know that the SBOM is most likely incomplete, okay? So we are clearly missing some information. If we don't know, okay, what kind of software is inside our containers, most likely we're going to miss vulnerabilities, okay? But on the other hand, we have a lot of other packages inside every container, a huge number of packages, and all these packages have historically a long list of vulnerabilities, and we are getting these enormous results, okay? Even without a complete list of components. And those who are tasked inside the organization with managing these things are in a state what we call CVE shock, okay? Because they are expected to handle these issues and trying to fight whether they are real issues, real security issues or not, constantly, and they are running for approvals inside the organization, running to the security teams, and so on. And it is a really, really hard task because we are getting enormous results, okay, today with these scanners. And if we're talking, okay, about, again, these results, okay, these results on the one hand, containing every vulnerability for every software inside your container. Okay, so for example, not just for example, I can tell you that the way today we are building container images have been designed in Docker in the early days in the way that every layer is building the next layer, right? And therefore, if we need some tool inside a container, okay, to build the next layer, okay, we need to have a tool inside. So therefore, we are installing packages inside our containers, which are only used during the building phase, but they are not included in the runtime phase. For example, okay, the simplest example is BusyBox, okay, for every Linux tool, simplest bash tool okay. It contains a huge, okay, bunch of vulnerabilities, and actually most of the time it is not used by containers. Because the main application usually doesn't need them, but it is needed for building actually the container images. Another example for here is libcurl. Okay, libcurl, right, is used for most of the 99% of the time for HTTP, and right, it is used for implementing HTTP protocol. But for example, if there is a vulnerability, and there was a vulnerability inside the FTP implementation of libcurl, and which is this vulnerability only is relevant for a given FTP use, then every one of us who have lib curl, okay, inside the container will get this vulnerability in this mess, and although it is super not relevant, right? And the other part is what the container vulnerability scan results doesn't contain, because it can only return vulnerability results for the packages it could discover. So all those packages it couldn't discover, it won't return any result, okay? And obviously it won't be able to discover zero-day attacks. Those who are not, vulnerabilities which are not known for the public are, you know, it cannot tell you about them. And obviously most of the time, you know, our images will contain some kind of code, you know, we are creating, right? So our companies are writing some code, we are containerizing it, releasing it, but obviously since it is our own turf, we are not really, you know, part of any vulnerability release information, therefore the scanners won't return any results for them. So a very, very simple example, okay? I've scanned, you know, 2 months ago with Gripe. I've scanned the latest Redis image, okay, which should contain all the latest security patches and so on, and scanned it, and it not just found 81 vulnerabilities, but among them it's something like, I don't remember the exact number, but at least 3 critical vulnerabilities, okay? Critical vulnerabilities should be something we should solve today, okay, as an operator, and 10 to 12 high level vulnerabilities. And you know, it made us think, okay? It made us think that how useful, okay, these results are, and how, you know, can we operate around them. And we created, you know, we did a research for ourselves and said, okay, let's try to understand what are those packages which are really used inside the container during runtime, right? So you remember one of the earlier slides where I told you that inside the SBOM, you can see the name of the package included, its version, and also the files it contains, a given package. So we know if we have the SBOM for a container, we know to which package contains which files. And with some, you know, with some tooling magic inside on a Linux machine, we started to run this Redis image, and we used, you know, ptrace inside from the kernel, and started to find out, okay, which files are touched by the container during its runtime. We created a list of those files, and you know, and checked which are the packages inside the SBOM where they are relating to. Okay, so actually we could say, using this very, very simple, you know, research, we could say which are the packages inside which are really relevant in the sense that they are used during runtime and not just build time of the container. Okay, as it turned out, there were much more or less packages used during runtime. Okay, and when, you know, we cleared out the SBOM from all those, you know, packages which are not used during the runtime of the container, and redid the, you know, the cross-check with the vulnerability database, it turned out that there were, I think, 12 vulnerabilities out of the 81 it returned. 12, okay? And none of them were critical. So all of the critical vulnerabilities, which I need, as an operator, I need to solve today, were irrelevant, okay? From the real application use point of view. And afterwards, okay, also there was only, you know, one vulnerability which had the high severity ranking, and we did some manual checks around it, and it turned out it's also not relevant, okay, for this application. So going from 81 vulnerabilities with 3 critical inside and 12 high vulnerabilities, it turned out we went down to 12 vulnerabilities and not a single high vulnerability and none of the criticals. And all the others were like negligible severities, which are, you know, just don't care. So, you know, this is just, you know, explaining to you, you know, as fellow operators, who need to deal with this work, that there is a long work ahead of us, okay? Because vulnerability scanning is a requirement today, and there's a compliance requirement with it. But if we need to start to act upon these things, okay, we can get into a state of really shock, okay, where there is no real reason for that. And you know, going inside, you know, working with the tech security at CNCF, we were looking around, okay, what's happening, who's working on this, and it turned out that there is an initiative inside the tech security called VEX. Okay, V is the document name. It's Vulnerability Exchange Document Format, which actually enables software vendors to release information about whether a given vulnerability is really relevant for their software. So in this case, okay, if Redis is able to release information about whether it is using libc or not, and by declaring that it doesn't use this libc, you can take out, you know, 80% of the vulnerabilities inside the container, which a vulnerability scanner returns today. So, again, the idea here is that, you know, creating a document, okay, inside in this process, okay, which can enable us, okay, to take the list of the vulnerabilities the vulnerability scanner returns to us, and you know, filter out all those which are irrelevant, okay. And who's going to be tasked with this, creating the VX in general, should be the software vendor. So, you know, we are in the early phases where I think that the governments are going to start to create procedures around software releases and SBOMs. But as a further you know, step, I think the next step is going to be that software vendors will be required, okay, also to create another additional vulnerability information for all of these containers. So in this document, okay, what you can see that there is a very simplistic example on the VX discussion page, where you can see that, for example, in this case, Cisco, as a vendor of iOS firmware, can declare that a given vulnerability, in this case, I don't see the number, but in any case, a given vulnerability is relevant for this release, and the code is going through, okay, and this vulnerability, and it can be exploited. So, in the general sense, okay, VX is a very, very early, you know, initiative, and it has a long way to go. But on the other side, it has important backers in the security, in the industry, and also, you know, from the government. And I think that what I think is the major question is going to be that who is going to create it? Okay, who is going to make this document, and who is going to maintain it, okay, because this is not a single document you can release once, okay. Maybe if you have a container image and you're releasing an SBOM file for it, it is one-time work, right? Because the container itself is immutable, okay, in its form. But on the other hand, vulnerabilities are coming up, you know, every day, and you know, if there is a vulnerability which potentially can, you know, affect your software you have released like 2 years ago, then actually you have to, you know, re-release your VX with the new you know, vulnerabilities included. So therefore, there is obviously a burden on the software vendor. Okay. On the other hand, this is information, okay, which can be created once and used by all the industry. Okay, and it can save a bunch of time for all of us. Okay, obviously, okay. The other question is who's going to follow, and whether will be any, you know, any different ideas of how to progress with. But I can tell you that I think that if it's going to be, you know, real, okay, and it's going to work, and people will create it, you know, I think everyone will follow, because this is I think that this is going to be a huge problem for every of us who will require to work with vulnerability scanning.